already, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Summit Academy. In this video, still working on our scientific notation. We're in Unit 7, Lesson 13. And so we're talking about switching between that scientific notation and standard form. So that's what we're going to aim to do for today. So we will be able to switch between scientific notation and standard form when working with large and small numbers. So make sure you can switch back and forth in between those two. Alright, so for the first one, talking about some numbers where we're multiplying by 10. So it says define the value of each expression. So what we can do is just multiply these out. So for this first one, I'm going to say I can count the zeros. So 1, 2, 3, 4 zeros. So I can count, I have 1, 2, 3, 4 zeros. And so I can put the commas in between those. So I'm going to say 1,230,000. Then for this one, it's almost like this is in scientific notation too, but I can multiply it out. So I have 1, 2, 3 zeros for this one. So I'm going to say for this one, I have 3, 4. It's almost like I'm moving that decimal place 3 times to the right. So I have 0, 0. Then for the next one, similar idea. I have to move that decimal place 2 times to the right. So I have 1, 2 times to the right. And so I'm going to say this is going to be 60. And then lastly for that one, it's almost like I'm moving that decimal 2 times to the left because of my smaller decimal place. So I have to go 1, 2 times to the left. So I have 0.073. Then after that, it says the table shows the speed of light or electricity through different materials. Circle the speeds that are written in scientific notation and then write the others using scientific notation. So we're going to say for this one, let's say that space, we can say for space we have to change it to scientific notation. So what I can do is I can count those zeros. So 1, 2, 3, 4, 5, 6, 7, 8. Or it's almost like I'm moving that decimal place 8 times to the left because I have a large number. So just make sure you can set it up either way. So, but it's going to be 3 times 10 to the power of 8. Then we're going to say for water, water is already in scientific notation, so water is good, so I'll circle that one. Then for copper, we're talking about electricity, we have that in standard form, so we need to change it over. So I'm going to say, okay, here's my decimal place. I need to move it in between the 2 and the 8. So I have 1, 2, 3, 4, 5, 6, 7, 8. So make sure it's in between those two values. So I'm going to say that I have copper is going to be equal to 2.8 times 10 to the power of 8. Then we can say for these other ones, I'm going to say that we need to change, let's change diamond to be in scientific notation because we need to have a smaller number. This number right here has to be in between 1 and 10, which it is currently not, so I need to make it a little bit smaller. So decimal place it right here, so I need to put it in between the 1 and 2. So this could be the same as 1.24 times 10 to the power of 8 now. So make sure you change the exponent as well. For ice is good because that one's already in scientific notation. Notice how it's 2.3. So that one number is in between 1 and 10. And lastly, let's say for olive oil, we need to move it 1 step to the right because we need to make it a little bit smaller. Or sorry, we need to make the exponent a little bit smaller. So we're going to say 2 times 10 to the power 8 now. So notice how each of those have that exponent of 8. And so when we look on our zoomed in number line, that's going to be counting by 2. So like this, I'm going to say this is going to be 2.1 times 10 to the 8. It's going to be 2.2 times 10 to the 8. And so each of those dash marks are increasing just ever so slightly. So it's 2.3 times 10 to the 8. This is 2.4 times 10 to the 8. This is 2.5 times 10 to the 8. 2.6 2.7, 2.8, and 2.9. So each of those little spaces, again, it's zoomed in because it's increasing by a small decimal place. But notice how in between these two numbers, so let me highlight these, make it a little bit darker here. I'll say again, notice how the far right end are already on there because the far right and far left end are already on there because that's what's being included. So just notice that that's how it's set up for this for this number line. All right. So now moving to the next part. It says you and your table partner have a set of cards. And it says some values are in scientific notation and some values are in standard form. Take turns grouping the equivalent values together. So let me do this real quick to show an example. So you should have a set of cards like this. So what you can do is I'm going to have these different cards, and what you can do is, if you notice, again, I have something like this is in scientific notation, or something like this is in standard form. And so what I can do is I can separate those like this. So I'm going to say, okay, I have scientific notation, and I have standard form, and then I have standard, scientific notation. Anything that has that exponent is going to be that scientific notation. So first, group these into those two groups, like so. All right. And if you notice, what then you can do is you can group them into, so you have your two groups. You have standard form and you have scientific notation. And so what you can do now is I can group them into large numbers and small numbers. And if I'm looking at the exponent of my scientific notation, I know that this is going to be a small number. So I can say, okay, this is small, small, this is large because my exponent is positive. So I have large number, small number, large number, and large number. Same idea with my standard form now. So I have small numbers and I have large numbers. Now I need to say for my standard form, I have to say, okay, this is going to be a small number. So is this, however, this is going to be a large number because it's almost like our decimal place is on the far right. So it's almost like the decimal place is here. So when I say large, large, small, small, large, large. Okay. So now what you can do is you can say, okay, well, now that I have these sorted, I'm going to move these to the side so that way I can match up. And I have these four here, and I have these four here. So now we just need to match up the ones that go with the right numbers. So if I match these up, again, I can either work with the standard form or I can work with scientific notation. Either way works. But what I'm going to say is this. I can count. I can say, okay, I have 1, 2, 3, 4, 5 decimal places. So I'm going to say that these two go together because it's going to be a small number, and it's almost like I'm moving it 5 times to the right. So 1, 2, 3, 4, 5. I should have 5 total zeros on this one. So that these two go together. I'm going to put those to the side like this. Now let's see. This one I should have 6 total zeros. So I have 1, 2, 3, 4, 5, 6. So these two go together. Moving on, for this one, I need to make sure if I moved it 7 times to the left. So if I have 5, 0, and my decimal place is here, what I can do is I can move it 7 times to the left. So I count 1, 2, 3, 4, 5, 6, 7. Place them in decimal place and fill in zeros everywhere else. So if I look at this picture, I would say, okay, well, notice how I have less zeros because I can cut that off. So I have 1, 2, 3, 4, 5, 6. So I need to have 6 zeros on here. So this one has 5, and this one 1, 2, 3, 4, 5, 6. So this one goes with this one. So let's put those two together. And I have, this is going to be 4 zeros to the left. So I say 0.5. I count 1, 2, 3, 4. That's it. So let me try that again. I count 1, 2, 3, 4, place my decimal place. I have 1, 2, 3, 4. So in total, though, I'm going to have 5 after I change it. So make sure you're able to change it from scientific notation to standard form. Or if you want to change it from standard form to scientific notation, again, I can move the decimal place 1, 2, 3, 4, 5 times. And so I'd say this is going to be 5 times 10 to the exponent of -4. So just make sure that you're pairing those together. Make sure you can do the same thing with the large numbers now. So now that I have those grouped, put them back together. I'm going to set these aside. And let's do it for the large numbers now. So I have my standard form and I have my scientific notation. And so I need to match these together. So let's find what we have. So again, if we're talking about our standard form, I have my decimal right here and I move it 1, 2, 3, 4, 5, 6 times to the right. So this is going to be the same as 5 times 10 to the power of 6, which is this one right here. So these two go together. I can match those like that. If I have this one, again, make sure you can change either the standard form or the scientific notation. So for this one, I can put 5, 0. And since my exponent is positive, I'm going to move it to the right now. So I have my exponent or my decimal point right here, and so I need to have 1, 2, 3, 4, 5 places to the right, and then I fill in zeros where the blanks are. So in total here, I have 1, 2, 3, 4, 5, 6 zeros. So I need to have 6 zeros, which is actually going to be this one here, because if I look, I have 1, 2, 3, 4, 5, 6 zeros. Okay, so those two go together. Moving on, we can actually say that these are going to be the same, but I can say, okay, if I have 0.5, move the exponent 1, 2, 3, 4, 5, 6 times to the right, fill in your zeros. So if I look at this number, this is 500,000, which is either of these options. So make sure, again, you can match those together using that standard form or that scientific notation. Okay, so try that out with your partner, and actually make sure that once you have all of them grouped together, make sure you check with me and make sure you put them back together like this. So I'll write that here in a second. So put them all back together, one pile, and make sure you put that paper clip on top. Okay, so let me write this as well. So we're going to say, make sure work with partner and check with me. Okay. After that, working on some of these practice problems, so I'll guide you through these. So it says the change or write each number in scientific notation. So make sure you're, again, taking your time, find where your decimal place is at. So for this one, I know my exponent is going to be positive since my number is larger. So what I can do, I can say 1, 2, 3, 4 times. So I'm going to say 1.47 times 10. Let me write that in. Multiply times 10 to the exponent of 4. For this one, my exponent is going to be negative because I have a small number. So I'm going to say I have 1, 2, 3, 4 times like that. So I have 8.3 times 10 to the exponent negative 4 this time. So make sure you can also check with Desmos if you need to see that expanded form or scientific notation. All right, so then for this one, I can say I have 1, 2, 3, 4, 5, 6, 7, 8 times. So I'm going to say 7.6 times 10 to the power of 8. And for the next one, I can say, all right, small exponent or small number meaning negative exponent. So I'm going to say I have 1 2 times to the left is what we're going to have. So we're going to say 3.8 times 10 to the negative 2 power. For this one's going to be just a small movement. So we're going to say there's going to be 1 time to the right. So I have 3.8 times 10, still to the negative 1 power. For our next one, this one's tricky because this one is already in scientific notation. So it's like we can just say we don't have to move it at all. So we're going to say it's going to be 3.8 times 10 to the power of 0 because we don't. So this is no, let's say no move on that one. However, for this one, it's going to be a really large one. So let me make sure I take it one step at a time. So let's do, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm going to say I have 3.8 times 10 to the exponent of 12. Again, notice how I have that positive exponent because it's a large number. However, for our last one, that's going to be a small number since it is it's going to be a negative exponent because it's a small number. So let's count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I need to make sure I move that decimal place so that way this number in front is in between 1 and 10. So I'm going to say this again, 9 times 10 to the negative 10 power, because I have a small value. All right, moving to the back, it says perform the following calculations. So express your answer in scientific notation. So what we do for this one, since the bases are the same, we can actually add our two exponents together. So I'm going to, add our two numbers together. So I have 2 plus 6 is 8, and then I have times 10 to the exponent of 5. For our next one, we can just multiply it by 2. So I'm going to multiply 4.1 times 2. So I'm going to say this is going to be 8.2 times 10 to the exponent of 7. Then for the next one, same idea, I can multiply these together. So I'm going to say this is going to be 4.5 times 10 to the 11th power. Make sure you remember your exponent rules from before. Since I'm raising these to the exponent, I have to multiply these together, but we have to also make sure that I'm doing I have to do 3 squared times 10 to the exponent 3 times 2 because of our exponent rules that we had from before. So I have to make sure that I'm distributing that exponent to both of those original exponents. So this is going to be, in total, it's going to be 9 times 10 to the exponent of 6. So make sure you're checking that one very carefully. Then for this one, this one's a little bit trickier just because we have a couple things. So I need to multiply these together because I have 3 times 9, so it's going to be 27. And then I have to add exponents because we are multiplying these together. So I'm going to say this is going to be times 10 to the exponent of 12. Make sure you make your number a little bit smaller though. So I have to have that this number is in between 1 and 10. So I'm going to say I have 2.7 times 10 to the exponent of 13. So make sure you're careful on how you set those up. All right, moving on to number 3, it says Jada is making a scale model of the solar system. The distance from the Earth to the Moon is about 2.389 times 10 to the 5th power miles. The distance from the Earth to the Sun is 9.296 times 10 to the exponent 7 miles. She decides to put Earth on one corner of her dresser and the Moon on another corner, about a foot away. Where should she put the Sun? And it gives you some options. So it says on a windowsill in the same room, in her kitchen, which is down the hallway, or a city block away. So what we can say for this one is the distance from the Earth to the Sun is about 4 times 10 to the second power, which is about 400. And that's times the distance from the Earth to the Moon. Since Jada's dresser is about a foot long, this means that her model sun should be about 400 feet away from the dresser. That means that Jada's apartment is not 400 feet long, and so the model sun should go down the block. So it gave you a couple options and kind of worked through it using that scientific notation. All right, and then after that for number 4, it says here is a graph for one equation in a system of equations. So let's actually find out what that graph is. So I'm going to say, well, I have my y-intercept is going to be at -3. So I can say, let's write it like this. Let's say b equals -3, and then I can find out what my slope is going to be. So I'm going to say my change in x is going to be +2, and my change in y is going to be +3. So find your slope, find your y-intercept, write your equation, and so we're going to say our equation is going to be y equals 3/2 x minus 3. So that's going to be our original equation. Then it says to write a second equation for the system that has infinitely many solutions. What that means is this, it just means it's the same let's say the same slope, and same y-intercept. And so if we want to, we can actually write it like a decimal. So we're going to say this equation that we could write is y equals 1.5x minus 3. So that's actually going to be the same as our original equation. Then for part B, it says write another equation whose graph goes through the point 0, 2, so that the system has no solutions. And so when it has no solutions, that just means that's the same slope, but different y-intercept. So again, real simple, be able to write these. So I'm going to say, let's do a little bit different one. So I'm going to say it's going to be y equals, let's say 3/2 times x, but let's have a different y-intercept. Well, it says it has to go through the 0, 2, so that's its y-intercept right there. So we're going to say it's +2. So our equation is going to be y equals 3/2 times x plus 2. And then for the last one, it says write an equation whose graph goes through 2, 2, so that the system has one solution at 4, 3. And so what we can do is we can actually graph, or we can come up with our equation using these 2 points. So I'm going to write it like this. I have 2, 2 and 4, 3. And so what I do is I'm going to say my change in y is going to be +1. My change in x is going to be +2. Make sure you write your slope like this. So I'm going to say my slope is still the change in y divided by change in x. So that's just going to be 1/2. And so what I can do then is I can come up with some points that are on this line. We know it goes to the point, let's say, where's that, 2, 2, so that's right here, and it has a solution at 4, 3, so right here. And so again, we can find our slope, and so if I want to, I can kind of mimic that pattern. I can build that staircase. I go to the right, 1 up, or if I want to go to the left, I go 1 down and to the left, 1 down to the left, 1 down to the left, 1 down to the left. So it should make, the pattern here. And also too, I can say, hey, there's going to be my y-intercept. So I'm going to say b is going to be equal to +1. So we're going to say our y-intercept is going to be equal to 1. And so we have the 2 parts that we need to write our equation. So I'm going to say, again, in the form y equals mx plus b. Again, we have this is going to be m, and this is going to be b. So we say this is y equals 1/2 times x plus 1. That's going to be our second equation. So again, make sure you can check those out. graph them on your wonderful picture, and make sure you draw the line that goes through those points. And lastly, for this one, it says, for the Lesson 13X ticket, it says switch each form from scientific notation to standard form and vice versa. So if it gives you scientific notation, write it in standard form, or if it gives you standard form, write it in scientific notation. So like this, I'm going to say, again, I can move, I have 5.23, I'm going to move it 8 times to the right. So I'm going to say I have 1, 2, 3, 4, 5, 6, 7, 8. So I have to fill in zeros everywhere where it's at. So I'm going to write it like this. I have, let's say 5, 2, 3, and then I have 1, 2, 3, 4, 5, 6 zeros. Okay. So I have your, let me actually write that a little bit better. So I'm going to say I have 5, 2, 3, and then 1, 2, 3, 4, 5, 6 zeros. Make sure you can write them like that. However, if you have something like this where you have to write this in scientific notation, so I have 4, 8, 2, 0, 0. I need to move my decimal place 1, 2, 3, 4 times. So I'm going to say that's going to be 4.82 times 10 to the 4th power. So make sure that you can try these out. So again, these are your turn. Be sure to ask questions as they come up, and as always, super slam that subscribe button.